the derivative of the numerator and the denominator. Key thing here is we're not doing the quotient rule. You're doing the derivative of the top over the derivative of the bottom. So here's the thing: if the limit is evaluatable, you can just stop at this point and you're done. The thing is, sometimes after you take the derivative, it's not. So can you do the L'Hopital's rule multiple times on one? Absolutely. You just have to keep on having an indeterminate form. That's the key. You have to have an indeterminate form for this to work. What are the two indeterminate forms? What are the two? 0 over 0 and infinity. So in this case, this is the evaluatable end step. Like if you're at a point where you can actually plug in a number, you're done. But until you get to that point, you are no, that's not right. You are not done yet. This is the last step. So this would be a single step right here. Oh, you do it once, you can evaluate it suddenly, and you're done. So what we're talking about is the more general form, which is if you can't plug in A, you keep on going. This is the rule that allows you to keep on going, which says the limit of the quotient of the functions is equal to the limit of the derivative of the functions, provided that it exists. So this is what allows you to keep on doing it. This step is what allows you to finish it. If it is evaluatable, you're done. The key thing is recognizing the indeterminate forms. The two indeterminate forms are infinity over infinity or what? 0 over 0. And those infinities can be plus or minus. That just affects the sign of the final answer. So you have to have an indeterminate form to run L'Hopital's rule. What happens if you run L'Hopital's rule on a quotient that is determinate, meaning not indeterminable? What happens when you run L'Hopital's rule when you're not supposed to effectively? Do you know what happens? You can get concrete answers that are just completely wrong. It's similar to integrating over a discontinuity. What happens when you integrate over a vertical asymptote? Do you remember? You get an answer like 7 or 12, and you're like, that's great. I am comforted by a real number. And it's like totally not correct, but it gave you a number that's nice. If you use L'Hopital's rule on something that is determinate, like you can just take the derivative of or find the limit of, sometimes you'll get answers that are really nice that are totally wrong. So the key thing to remember is, do you have an indeterminate form? And if you don't have one, sometimes you force it. Sometimes you rearrange things. Sometimes the indeterminate form is hidden. The key thing to remember is it's plus or minus infinity over plus or minus infinity, or 0 over 0. What about 0 over infinity? Or infinity over 0? You have to be real careful with those. It don't fit.
0
is it just infinity?
No.
Is it? It could be. I think it could be. Because you're getting infinitely small, it blows up. It doesn't exist, right? So you just have to be careful. You can use L'Hopital's rule in the indeterminate cases. So let's actually try one. The first question to ask is this an indeterminate form? Can someone state explicitly if this is an indeterminate form? Is it? Well, what's the limit as x goes to infinity of 5x plus e to the negative x? What's that? What is it going to be? 5? It's going to infinity. So what's it going to? Infinity, yes. Okay, what about the limit as x goes to infinity of 7x? Is this an indeterminate form?
Yes.
Because the other one is, so this is infinity over infinity. I don't expect you to do this every time, but you need to run it in your head. Do you see how I circled infinity over there? That will signal to me that you are stating that it is an indeterminate form of infinity over infinity and that you've thought about it. So now what do we do to the top and what do we do to the bottom? Yep.
Wouldn't it be like 5 infinity or 7 infinity?
So you want to like cancel the infinities? Just remember, infinity is not a number. No, it's fine. It's a concept. You can't cancel infinities because things can go to infinity at different speeds, right? Okay. You've seen this before many times. Like, what about this? What's the limit as x goes to infinity of like, so in this case, so yeah, that's infinity, so that's just 1, right? Infinity over infinity in that case. Well, what's the limit as x goes to infinity of x squared over x? Well, the top goes to infinity. And so does the bottom, right? Yeah. But what's this equal? It's indeterminate, right? So just because it's infinity on top and infinity on the bottom. Exactly, but this is the rule that helps us with that. So now take the derivative of the top. What do you get? 5 e to the over. Then you ask yourself, hard stop, is this an indeterminate form? Don't keep on doing L'Hopital's rule unless you have an indeterminate form. Is this an indeterminate form? Definitively not. Why? 为什么？什么 G? 1, 2, 3, 4, 5, 6, chi. 7 ain't indeterminate. It's very much determinate. So you ask yourself, can I now do the derivative, or can I just do the limit? And what do you ask? I can do the limit. So what's this going to be? Well, you just need to remember, what's the limit as x goes to infinity of negative, or just e to the x? Oh, e to the negative x. What's that? 0, right? So what's this going to be? 5 over 2. You're done. You are done. We had one indeterminate form. Now, the one notation you can use, in addition to infinity over infinity, you'll see this, the equal sign with an h over it. What does that mean? You have applied L'Hopital's rule. I have applied L'Hospital's rule. Yes, you do. It tells me that you use L'Hopital's rule. Yes. Do you have to capitalize letters? In English, do you capitalize lots of letters? Do we really have to transmit meaning? Could I delete could I delete the vowels in most words, and would you understand what's going on? Yeah, actually. If I scramble the letters that are not the first and last, if I keep the first and last letters of words the same, but I scramble the middle, can you actually read it pretty well? Yeah, you can. What happens if I do all of those things? It gets real hard to function. So we're just going to have nice manners in math and have grammar that makes us look, what's it called? Literate. Oh, that's the word. Okay. Is this an indeterminate form? How do you test it? X to infinity of, what's this? Oh, x going to 1. I'm sorry. X going to 1. What's this going to? 0, right? And what's the limit as x goes to 1 of 1 minus x plus ln x? It's also 0. So this is 0 over 0. So what am I going to apply? L'Hopital's rule. So now you have to be super, super duper careful, kids. Do this for me. Write out what the next form is. It's the limit as x goes to 1 of what? Please find that out for me. Be careful. Please be careful. You do it. Don't know hints. I know you've seen what's not cool. Just no hints. Come on, Charles. Let's do the bottom. What's the bottom one come out to be? Negative 1 plus what? Negative 1 plus 1 over x. Nice. Look at that. Look at this. What do we have here? Oh. Yeah, that's nice. And we know the derivative of x is going to be just this, right? We have minus 1. Oh, if I can actually get this to... Hello. Give me this back for a second. Hello. That's why I use this one. There we go. Is minus 1. So what's the entire thing we need? We need that, right? So what do we need to do? We need to do d dx of what? X to the x. This is something that I'm pretty sure was on a homework assignment definitely towards the beginning of the year, but it's so far back that even I have trouble remembering. Do you remember what you have to use in order to do the derivative of this? Can we list all the different ways people do this wrong? X times x to the x to the negative 1. Like, no. So, any ideas? Yeah, you have to do something here. So look at this. You have to do logarithmic differentiation. Do you remember this? You have y is equal to x to the x, correct? Do you agree with that, right? Okay, so what do you do here? ln y is equal to what? ln x to the x, correct? You with me so far? So then you have, do you agree that this is still, I haven't broken any laws in terms of math here, right? So ln y is equal to what? X ln x, correct? So now you need to do implicit differentiation. Y is a function of x. What's the derivative of ln y implicitly? Do you remember? It's 1 over y prime, right? Do you remember that? Do you remember that, everybody? Well, it is. It's implicit differentiation. It is. It's 1 over y prime because you're differentiating with respect to x, but it's y. So what do you have to do on the other side? Product rule. So the derivative of the first times the second plus the first times the derivative of the second. So what do we have here? 1 over y prime is equal to ln x plus what? 1, right? So what does that tell us y prime is? Y times what? Ln x what? Plus 1. What does y equal, everybody? Look. Oh, wait, I highlighted the wrong thing. Y is equal to what? So what does y prime equal? X to the x times ln x plus what? Plus 1, like that. So where do we plug that in? Right there. So what do we end up with? X to the what? Times what? Plus 1, yep. Is that -1, right? Okay, so now we ask ourselves, are we in a better place? I mean, that's kind of a question you should ask yourself. Oh, come on. Well, hold on. Hold on. At first, you're like, and then you're like, and then you might be back at So what did I say to evaluate? Once you've applied L'Hopital's rule, you try to see, can you do it again? Well, here's the thing. Is it an indeterminate form? Well, let's look. What's the denominator? The denominator is 0. Do you agree?
Yes.
Okay, so what about the numerator? What about the numerator? 1, 1, it is 0, right? But here's the thing. So is this technically an indeterminate form? Technically, it is an indeterminate form. But at this point, does it seem like it's helping our cause to continue? Oh, no, I'm asking serious questions here. Does it look like it'll help to continue? Not really, because does it look like the derivative is going to be any better? The reason why was L'Hopital's rule really helpful here? What happened in terms of complexity as we moved to the right? It got better, right? It got simpler. The thing here is we know, because you've done hundreds of derivatives and thousands of derivatives, just derivatives don't always get more simple, right? Does that get simpler? The bottom does, but great. The bottom got simpler, right? So theoretically, what would we want to do next? Well, if we wanted to apply L'Hopital's rule again, everybody, what does the bottom become? So this is x. This is -1 plus x to the -1. What does that become? It becomes what? Negative x to the -2, right? Do you agree with that? So what do you have to do on top here? You'd have to do the why. Can you tell me one thing about why this is actually really good? Why does this make us happy? It's not 0. It's not 0. So if we end up with something on top that is evaluatable of anything, we're done, right? We are done. Do you agree? And at least what cancels here? Yes, there's one thing that, well, you're right. Actually, the parentheses prevent it from canceling. Sorry, never mind. No, it doesn't, because there's this on the outside. Yes, if you take the, oh yes, when you take the derivative, it goes away. I was talking about, is there anything that simplifies that we can get rid of before? No, it doesn't. So what are we looking at here? We have x to the x, ln x, is it -1 or +1? +1, right? We don't really care about that -1 because it's just going to go. So if we wanted to do the derivative of that, what's it going to be? What rule do you have to use? Product rule. So the derivative, what's the derivative? We already did it. What's the derivative of x to the x? X to the x, ln x plus 1. That's the derivative of the first times the second, right? Plus the first times the Sorry. Is that okay? Is that better? Thank you. Thank you. Plus, so that's the derivative of the first times the second, plus the first times the derivative of the second, correct? And we're doing this, the limit as x goes to what? 1 of that. What's that going to be? 1 to the 1 times 0 plus 1 squared plus what? 1 to the 1 times. So that's going to be limit as x goes to 1 of what? 1 plus 1 is 2. So you go back to this. When you're doing the limit on this x going to 1, what does this go to? -1. What's the top go to? So the answer to this is? Oh, I know. Beautiful. This is where we hope we didn't make a simple mistake, right? Okay, more practice, more practice. I think I have a board one for you. Oh, look at that! How'd we do? Look! Look! I love that. Did we do okay? Come on, it makes you feel a little good to do all that work and get the right answer.
Not really.
Yeah, no. So here's the moral of the story, or morals. First one is logarithmic differentiation. Coming up with this derivative, you're going to need to remember how to do that. It's a rare thing to do, but sometimes it happens, and it's fair game. And then also, this is notation heavy, but this is not quite nasty enough to be excluded from the BC exam. They could ask you something like this, definitely. So here's the thing. Even with the Carroll's, math makes you sad? Yeah. Oh, come on. Yeah. I applaud your effort, Mr. Seamon, but it's a losing game here. the losing game. Okay, I know. I'm mixing in indeterminate forms, L'Hopital's rule, and logarithmic differentiation. I know what you're going to be talking about at lunch. Okay, the challenge here is even if you memorize, and even if you remember that this exists, recognizing that you have a valid indeterminate form or forcing it to exist, it can be challenging. So what are we talking about? 0 over 0, infinity over infinity. But then there are other battles that go on that we can use this tool to solve. So for example, what happens when you multiply something that's infinitely big to something that's infinitely small? There are 3 outcomes. What are the 3 types of outcomes? Infinity wins, or there's some sort of tie, and the answer is like 7, right? Just because you're multiplying something by 0 doesn't necessarily, or going to 0, it doesn't behave like it is 0, right? Going to 0 is not the same thing as being 0. So what do I mean? I mean things that look like this. First of all, is that immediately identifiable as something you can use L'Hopital's rule for? Immediately. No, because you're looking for fractions, right? But is there a fraction that you can create in one step without changing anything about the value? Exactly. This is infinity of what? X over. And is that an indeterminate form? Infinity over infinity. So we apply L'Hopital's rule and we end up with the limit as x goes to infinity of 1 over e to the x. And what's that? That's just 0. Because what's e to the something getting infinitely big? Huge. 1 over huge is going to go to 0. So sometimes it's slightly hidden. And I'm giving you major hints that this is what we're looking for, so it's a big hint. But it gets a little bit more fun because you end up with questions that look like these, okay? So let's look at the first one here. First of all, there's no negative exponent. You're like, oh man, what happened? I really wanted there to be a negative exponent, okay? Well, is there any way to force it? Well, let's try something here. The limit as x goes to 0 from the right of ln x over what would be the same thing? 1 over x, right? Is that the same thing? Is that the same thing? We are purposely making things more complicated to suit our needs. What is the limit of ln x as x goes to 0? What's the top limit going to go to? What's the limit as x goes to 0 from the right? Oh, good job, Tomas. Is what? Negative infinity, right? What's the limit as x goes to 0 from the right of 1 over x? Positive infinity, right? It's going to 0 from the right. Right? So is that an indeterminate form? Yeah, you would say negative infinity over infinity would be super helpful because they would mean to me that you did out the work. Or you can do that in your head, that's fine. So what do you have to do to both top and bottom now? You apply L'Hopital's rule, use the h, so you have the limit as x goes to what? What is 0? X goes to 0 from the right. What's the top become, Derek? Yeah, and what's the bottom become, Molly? Negative x to the negative 2. And then you ask yourself, yes, is this L'Hopital's rule? But what's the first thing you should do before you do anything else? You can check to see if it's still indeterminate form, but you can also do what to this? So yeah, first of all, you could check to see if this is indeterminate form. What could you say? What does this look like? This is the limit as x goes to 0 from the right of 1 over x over negative 1 over x squared. Are both of those, the top one's going to be positive infinity and the bottom one's going to be negative infinity. This goes to negative infinity and that goes, so is this still indeterminate? Is there something we can do to this first though, everybody? Yes, yes. So in addition, you can't forget, look for simplification. Look for simplification. So what is this? This is x to the negative 1 over negative x to the negative 2. What does that simplify to? Negative x to the what? No, negative x to the first power. This is the same thing. I'm not applying L'Hopital's rule. I'm just doing algebra as this. Right? So as you go to 0, what does this equal? 0. Don't forget basic simplification. That's the moral of the story here. Okay, what about this one right here? What about this one? Okay, go back. Yeah, sure, sorry.
How did you get to
It could tie, right? There's another one in there, which is, what happens when you take infinity to the 0 power? Or going to 0, not to the 0 power, going to 0. I don't know. It's the same idea. Infinity could win, 0 could win, or it could be a tie. It depends on how fast they are. What's the other one? 0 to the... Yeah, what happened? Oh, gosh. It's getting infinitely small, and it's getting to the infinite power. I think it's going to 0. But what about this one right here? Which form is this? This is infinity to the... That is an indeterminate form we can play with. So this is what you do, everybody. You go real careful on this. You say y is equal to the limit as x goes to infinity of x to the 1 over x. You need to be real notation careful here. What do we like to throw in at this point? We already practiced this today. What do we throw in? What do we throw in, T? ln on both sides. So you know ln of y is equal to the natural log of the limit as x goes to infinity of x to the 1 over x. Are you with me so far? Are these valid operations? Here's something I'm just telling you you are allowed to do. You are allowed to switch the ln and the limit. You are allowed to do that. That is mathematically proper. The natural log of a limit is the same thing as the limit of the natural log. I'm telling you you're allowed to do that. We're not going to prove it. There are a ton of things we do in calculus that we don't prove, that you don't even think we need to. That's what you take. Oh, there's a whole class in college called analysis, which is effectively proving all the stuff in calculus you took for granted, that you didn't even know you were taking for granted. So this is going to be, what's the next step? Natural log of y is equal to the what? Limit as x goes to infinity of ln of x to the what? Do you agree with that? Well, you told us it was okay, so we'll believe you. What can we now do? What can we now take to the front? What's the whole cool thing we can do now? Yeah, so we have the natural log of y is equal to the limit as x goes to infinity of what? 1 over x, ln of what? Do you agree with that? Let's simplify it a little bit. ln of y is equal to the limit as x goes to infinity of what? ln x over what? X. We're trying to find the derivative of y, correct? That's what we're trying to find what is the derivative. And that can be evaluated. So what we're doing is we're putting it in the form and we're evaluating it, everybody. And we're evaluating it. So if we want to keep on evaluating this, what do we do? We take derivatives of both sides. Give that a try, everybody. See what happens. See if you... I want you to basically do this now. Is that a limit you can... Oh, it's frozen. Is that a limit you... Like looking inside that purple, though, just look at the purple. Is that a limit you can use L'Hopital's rule with? Solve it for me. Go. Just quickly, everybody. Is that indeterminate form? Yeah, ln of x is x. It's infinity over... What is it? It's infinity over what? So what do you do to top and bottom? So this is the limit as x goes to infinity of what? 1 over x over what? So what's that going to be? 0. So what does that tell you? It tells you that ln y is equal to... So what does y equal? No, what does y equal? 1. Y is 1. Y is 1. And what did we say y was originally? This. So what does this equal? 1. Be very careful. You'll do so. Hey, look. Is that our friend already? Yeah, it is. Oh, and then you'll love this, too. Tonight, everybody, I'll edit the homework a little bit. We didn't quite get through all of it, but just make sure you look at the homework.